First, thanks a lot for joining my talk. I'll start with a short story, fixing bugs in legacy. Sometimes, the first time I encountered the TDD or unit testing practices, it was maybe something like 15 years ago, and the guy who was introducing this in the team told us, whenever you're fixing a bug, try to add a test around it. And the code I was working in at that time was kind of pretty difficult to work with, actually. And it turned out that just fixing the bug might involve one line of code and maybe a few hours of digging into the code base, but adding the test, that could take weeks, maybe one or two. So I don't know if you've been in this situation. You can wave your hands in your way. I don't know. But anyway, I'm sure a lot of you will connect to that situation. So let's see what we can do about that. So very quickly, a word about myself. So my name is Philippe Bourgau. I've been a C++ programmer from around 2000 to 2010. And since then, I've more of a polyglot programmer. So be nice with me. I am not really completely up to date with all the latest features of the language. But now I'm a technical coach, and I'm involved with teams who deal with legacy code in different languages. And with time, I've discovered different techniques that can help people who are dealing with legacy code. And that's what I'm going to show you today. I'm also a blogger. You can see my URL at the bottom, and I also work at Murex. And so a quick word about Murex. Murex is a sponsor for this conference. We're about 2,000 in the world, more than 500 developers. We're building software for the financial markets. So the nice thing about that is that it's very diverse. There's some performance things, some math aspects. There's also some low latency things. There's a very deep domain. So it's kind of interesting. And if you're interested, so obviously Murex is hiring C++ developers because everybody wants developers at the moment. So if you're interested, you can follow the company on the social media. And that's it for the initial presentation. Let's dive into the code. So this talk will be mostly live coding. And to do that, I'm going to use a repo that we created, which shows how a fix can be easy and the tests can be long to write. So it's not pure legacy because it's small, but it shows the difficult aspects of setting up your test that you can encounter in legacy code. The codebase itself is something, it's like a reporting and invoicing system for an online bookstore. And as you'll see, this code is available on GitHub, and it's actually part of a workshop. It's meant to be a workshop. So a workshop that if you want, you can get the code at your place and practice this workshop. Usually it takes about 2 to 3 hours, but I'll just go over this a bit more in detail at the end. And so today what we're going to see is that we found 2 bugs in this code, and we would like to add some tests around them. So let me show you what it looks like. So the code is here. Back. Let me. Here it is. Easy bug. So it's a customer portal. It creates some invoice, some reporting, and it's dealing with some exchanges, currency exchanges. So there's some different rates, and there's also some different tax rates applied depending on the country the invoice was sent from. And we found 2 bugs. So the 2 bugs are that we're expecting a value of that for our test case, and we're getting this. So let's see if we can reproduce this in the source itself. So here's the source code. There's an app here, and so we've in the code itself we've fixed the bugs. So here it is. You see here, this is the buggy code that was there, and we've added a fix. So let's first try to reproduce the bug. So you see just two lines to fix. Actually 3, but the problem itself is a lot more. Here it is. Let's run this and let's see if we can reproduce the bug. So we're getting this value, which is exactly the actual value here, and we were expecting this. So, and if we put back the initial, the fixed code, we'll see we get the expected value. 400 something. So what did we do exactly? So here in this report generator, we forgot to convert to USD. So that was the first bug. And there was another bug in the invoice where we forgot to apply the tax rate. So yeah, pretty obvious in hindsight. And it should be fairly easy to test. And that's what we're going to try. Because you know the rule, here it is. Should we always unit test bugs when correcting them? And if you check this software engineering page here, you'll find that the overall answer is yes, we should. Unfortunately, that's fine in theory, but when you've got really difficult to work with legacy code, it can really turn into a kind of a nightmare. So often the first time you do this, it's going to take you a lot of time. And after a few times, your code base will become more and more testable and it's going to become easier. But yet the first times are really difficult to work with. And today we're going to see 2 techniques that can help you against that and that can really make things easier to swallow, let's say. And so let's try. So the first thing we're going to try is we're going to try to reproduce to test the bugs in the most brute force way we can think of. So I've got some test templates here. So you see this is for the workshop. So in this workshop, the workshop is using the code retreat. So we're going to try the same thing using different techniques. And at the end, we'll learn what are the best technique or what is the best technique or the best combination of technique to be able to fix our problem or to deal with our problem. So let's first enable this test. And let's make sure first it runs. So it's empty, so obviously it's going to pass. But then we're going to try to write it. So fine, at least it's running. So what we would like, so you see what we want to do is instantiate an invoice sent to USA, add it a purchased novel costing, and then the amount should be 56.35. And we are applying the correct taxes and all. And this is to test the invoice, so to test the bug in the invoice. So if I start by the assertion, 56.35, and I should add an invoice. And if we check the invoice, you see the function that was bothering us was, where is it? Compute total amount. So let's see here. If we compute total amount of that, that's what we would like to do. So we don't have the invoice yet, so let's do that. So where's the invoice? So the invoice is in a package called purchase. It's a class invoice, and it needs a name and a country. Okay, so let's start to do that. So purchase invoice, and we'll send it to Jane Doe. Okay, and the country. So we still need the country. So let's add an include for that. That's okay. And then here we need a country. So let's check what this country is. So domain, country. Can we find this somewhere? Yeah, here it is. Domain, country. It's got a name, a currency, a language. Currency is an enum, so that's going to help us. And language is an enum. So we should be able to instantiate this country. So let's do that. The test says an invoice sends to USA. So let's do that. the domain country, and we want USA. Then there was a language. Where was that from? It was current. So yeah, it must be the same package. Domain. Sorry, namespace, not package. You're gonna hit me. I think it was currency first. US dollar, and then domain country current language English. And that's working. It looks like it's working. And then it means we should be able to run the tests already. We didn't do this step, so so what's happening? I must have forgotten something. Where did I forget something here? Semicolon. Okay, and we see here we get 0. Yeah, we didn't put anything in the invoice, and so obviously the amount is 0, and it should be that. So okay, so let's try to add something. So let's see what we have here. Add purchased book. That looks like a good idea. Purchase book. What is that thing? Purchase book. So purchase book is from the purchase namespace, and it takes a book and a quantity. Quantity is easy to provide. We'll just give 1. And purchase book is something. So, and here we are expecting, I think we are expecting, yeah, a shared pointer. So let's do that. And it was, I think, purchase book. And here it needed something. There was a quantity 1, so that's easy to provide. Do we know purchase book? It looks like it. Yeah, it looks like we know it. That's good. What else should we? So a book. It was a book. Let's see what the book is about. The book is here. So domain. Oh no. Book. So book, domain book, book. So book is an abstract, fully abstract class. And so here's the novel. Novel is here, and I think the test was telling us how to purchase novel. Okay, so what we need to do here is to make a novel. So let's go make shared, and it was domain book novel. So it looks like it doesn't know. So yeah, let's include novel. So my ID is very handy in all this. Unfortunately, very often in big code base we don't have such nice things, but you can just a bit more time managing through all the code, looking through all the code. So what do we need to instantiate a novel? So we need a name, a price, an author, a language, and a vector. So we can provide an empty vector. The language, it's in enum, should be easy. The price and the name, it's easy as well. We just have the author to deal with. So let's first deal with the rest, and we'll see that after. So I'll do it here. So name, I'll Grapes of Wrath from John Steinbeck. Let's say this costs 10. Oh no, they said 50, so 50. 50. The author, so we need to deal with the author. The language, we add this above, domain, country, language, English. And the vector, std vector, it was genre, it must be in the same domain, book, genre. And we'll just provide an empty vector here. That should be fine. And so we're still missing the author. So let's see what the author is. So the author, he's got a name and nationality, a country. Oh, we've got a country already. So that should be fairly easy. Let's just do domain, book, author, John Steinbeck. Okay. And for the country, let's. I'm a bit in a hurry now, so I'll just go and paste this. Should be good enough. It's USA, USA. Make sure, or maybe it doesn't know the purchased book. No. So I'll add that. Purchased book, that's it. Yeah, I don't know why sometimes it's using different quotes. Anyway, let's see if this works any better. Oh, actually the test is passing. Wonderful. So it looks like, I just want to make sure if ever I uncomment this and decomment that, and I run it again, let's see what happens. Will it fail? Yes, it does. No, it doesn't. 0. Shouldn't be. Oh, I forgot. I shouldn't have commented this one. Let's see exactly. This is the test I wanted to fix. The bug I wanted to fix. And here we've got, yeah, a different value, 50, which is not converted. Okay, great. So that was the first iteration. The problem is that I just tested one bug here. So I need to do this again, the same thing for this other one here. So instead of going through all that again, I'll just revert all this and show you what it looks like at the end. Good. Check out CPP. Here we go, and you see that we've got again some tests. So there's some static initialization thing, and then again some USA constants, country constants, some code here that looks pretty similar to what we had below. You see an invoice, a book, the same price, and then some other things. So okay, so let's roll back to get it back in a clean state, and let's get back to the. So sorry, it looks like this didn't work. Roll back, and let's go back to the presentation and see what happens. So here I just went through the first test. So it took me about 10 minutes, more, a bit more, a bit less. When I did it full, it took me 9 more minutes for the second test. So which means that the time for the first useful commit was about 10 minutes. And I had only 2 useful commits. And as we saw, the test code quality is pretty low. And we didn't really improve the testability of the code because we didn't touch the code at all, actually. We didn't add anything to make the next test easier, except codebase, which is not really what we want to do. So it's kind of painful. And in legacy code, it can become a lot more painful. We went through a kind of mini tunnel in these 10 minutes, during these 10 minutes, but it can become much worse in a large legacy code base. And on top of that, we're not necessarily happy with the end result because there's a lot of code duplication in the tests. And all this time taken to add tests, it encourages to use mocks. And mocks in legacy code sometimes really they don't really make the design better, and very often they make the code actually more difficult to change than it was before, because now you've got all these mocks that kind of mimic the structure of the code, and that makes it even more difficult to change. So that's not really the ideal solution we would like to have. And so let's see what we can do differently. So I know a pattern called the test data builders. I don't know if you know about this pattern. So anyone, maybe you can raise your hand if you do. The idea is to use the builder pattern. So yeah, I see a few hands raised. The idea is to use the builder pattern to help you build test data. So basically, you're going to use some dedicated classes to create some test data with some valid inputs and some easy to define test data. It avoids duplication between tests and it makes tests more readable. So for example, here is the instantiating the invoice with like what we did. So you see it's very verbose. We've got all the details of all the data, everything is there. And here is what it would look like with the test data builders. Here we're just specifying the interesting things, or the things that are important for us. So from France, and that it's a novel and that it's got a price. That's all we really care about. The rest is pure noise. And we don't want to specify this, and we don't care about the value of these. So we'll try to do the same thing now using these test data builders. So I'm back to my CPPP branch, and I'm going to try again to do the same thing. So here, this is the test I'm going to use this time. So using the test data builder, doing the same thing, the exact same thing. So let's first make sure the test runs, and we'll see what we want. So let's start with the assertion. Same thing as before. So the test is executed. So we've got an invoice, and this time to instantiate this invoice, we're going to do it differently. So we would have auto invoice equals an invoice. That's what we would like to have. So from, let's say, USA. Let's assume we have a constant for USA with a purchased book of a novel. So you see it's very kind of fluent to write. So the novel, what we are interested in about this novel, that it's costing 50. And we want to build this. That's what we get. So obviously this is not compiling at all. So, but now, so we've got these two steps here, but now at least we know what we want to do. So let's start. So we need a function first that's going to instantiate an invoice. So invoice test builder. That's what we want. And return, here we go. We just return a default invoice test builder, which means that now we need this class, invoice test builder. Okay, that's what we want. And what we need in this invoice is that we'll need a build method at the end. So we can add that. Public. It's going to return an invoice, and we'll call this build, which can be const. And it's going to return an invoice. So, oh yeah, we need to add the namespace, purchase, if I remember correctly. Purchase. So what did we need? Oh, so I need to include that. And let's go to the definition of that. So the invoice, it needs a name and a country. Okay. So a name, let's say Jane Doe, like before, and a country. And for the country, we would like to have some sensible default. So what we can do, we'll need some defaults here as well. So let's put this here. We don't really need a builder for this, but so we'll just create some default value, namespace test countries, and let's say we've got a const domain country France. And what do we need here? If we go here, we need a name, a currency, a language. So France, domain, country. I think it was currency first. Euro, domain. country, language, English. Okay, how does this look? Okay, it looks okay. So it means that now we should be able to use test countries. France, okay. That doesn't look so bad. So yeah, I can maybe replace this by that. Okay. So we've got this build, at least that's working. So, but we're not done yet. So we need this from USA. So let's add that. Invoice test builder reference from, and it was const domain country country country. And now what we would like, so first it's a fluent interface, so we know we'll need to return this. And what we would like to do is to change this. So it means that for that, in the builder principles, what we'll do is that we'll create a field for this one and we'll store it there as the default value. And then whenever we want to change it, we'll change it here. So let's try to do this. We'll call this country. We don't want it to be like that. And this, we would like it to be a field. Okay. And maybe we can rename this like that. Okay, here it is. And what we would like to do is this country equals country. That's what we would like to do. So does this work? Oh, it doesn't. So it turns out this country class, it doesn't support the assignment operator. So again, a glitch in that we might have in legacy, but I think also that it's immutable. So what we'll do is that we'll put this in a pointer so that we can change it later on. And so here we have that. And now, so we need obviously now to get a reference from that, or the value from that. And, oh, it looks to be working. So, but we still don't have this. So, so you see, I could continue like that. And I've only done these 3 methods, but it's going to take me a lot of time. So I'm not going to go through the full builder thing, because you see that I'm even in a longer tunnel. So what I can do instead is that I'll revert that and I'll show you what it would look like at the end. Git checkout CPP builders. Here we go. So if we do that, this is the code we have. I can run it. It should work. And so I've used the same code for the. So let's see. So the 2 tests are passing. And you see that I've reused a lot of the same code for the report generated test for the second bug. And if we look at the builder code, it's all over here. So just a few methods, all with this kind of same pattern. It's very similar, some default values, and even down to the author test builder and the test countries. So that a lot of factorized code and cleaner tests. So that's the main takeaway from this. So let's see exactly what happened. So if I had continued like that, it would have taken me about 30 minutes to get to the first invoice test. So the first commit I could do would be at that time as well. And the time then to add the second test would be only 7 minutes. So it's a bit faster than the first technique, knowing that the first technique we actually used cut and paste to make it down to 10 minutes. Only 2 useful commits, but the nice thing here is that the test code quality is good, and we improved the testability because now we've got builders that others and ourselves can build on to add more tests. But the cons is that writing the test data builders is even slower, so we're even in a longer tunnel than before. But there are pros, as we said, the tests are more readable, there's less duplication in tests, it would make adding new tests easier, and yeah, that's it, sorry, I just jumped ahead. So now let's see a second technique. So remember this overall workshop, the idea is to try different techniques at the same problem and then learn what works best for you. So we're going to use the Mikado method. So the Mikado method is a refactoring technique that is, so let's first see who has heard or knows the Mikado method. You can raise your hand in the... No, nobody, so I'll teach you something great. So it's a technique, a refactoring technique explicitly there to avoid tunnel effect. So the idea is that we'll create a graph of the different steps that are needed to do the refactoring. And instead of doing all the refactoring in one single big bang commit, we're going to split it in small steps and split it in very small commits and start by the commits that you can do without dependencies to other steps. And all you need to be able to use this technique is an end goal and a non-regression criteria. So your non-regression criteria can be different things. Usually we use compilation. We can also use smoke test. We can use automated tests. Whatever you have, the more secure, the better. But the nice thing about this, as you'll see, the nice thing about this technique is that you can always roll back to the previous state. So it's a bit of a routine as well. So that makes it easy for the brain and lets you focus on other things. So here's how it goes. First, you try to do your change. And then with your change, you check for regressions using your non-regression criteria. You can try some trivial fixes, what we call scratch refactoring. It also helps you to understand exactly what's going on and what might be needed doing. And if the non-regression passes, then it's great. It means you can commit what you did. And if that was your end goal, then you're done. But if your non-regression did not pass, then what you would need to do is extend your graph with the prerequisites, if you found any, and then revert, which is the very non-intuitive step. So you revert to get back to your code as it was working just before. And then you'll recurse on the prerequisites. So if you want a more visual way to do that, is that you add a node to your goal, you try to do the change, you check for non-regressions. If it's okay, you can commit and you can stop if your end goal is reached. If you can't, you revert, you extend your graph, and you recurse. So what we could do is use the Mikado method to try to unit test the bugs without using the test data builders. So I won't do this step because otherwise it's going to take too long. But just for you to know that what we would see in that situation is that we would get rid of the tunnel effect. We would be able to do small commits regularly. It's a lot safer. The fact that we can split the thing in small chunks, it buys us kind of time to avoid the stress to put some mocks. We can even use the graph as a team communication tool, so meaning that you can parallelize work all together using this graph. And you can use this graph to parallelize some work. So that's great. But there are cons still. There's still some code duplication between the tests because you'll get to the exact same code that I got to using no technique at all. And you might even have some duplications between the two graphs if you use the Mikado method for the two tests. So what we're going to try to do now is that instead of trying to test the bug as soon as you fix it, we're going to start the Mikado method using the test data builders to unit test the bug when we correct it. And so let's see what this would look like. So first, I'm going to get back to the start. Here we go. Here we go. And it's going to look, at the beginning, it's going to look pretty similar. And I'm going to use my test expressions to discover the steps I need to do. So what I would like to have at the end is something like that. Invoice.compute total amount. That's what I would like to get. And what I would like to have is something, again, an invoice dot from USA dot with a purchased book of a novel. So the novel would be costing 50, and I want to build this in an invoice object. Okay, so if I try that, I get a lot of errors. And here is where I'll start my graph. So if I get back to I'm using a mind map for that. So I want to test the invoice bug. And what we've just seen is that to do that, I'll need an invoice, all this expression to be okay. So the nice thing about the builders is that they're already kind of a graph, so it's going to really help me a lot to write this thing. So I would like the uninvoice build. So that's what I would like to have, the expression I would like to be able to run, to write and compile actually. And to do that, I'll obviously need a simple invoice test builder. I'll need that. What I would need as well is a from a currency here. So I'll say invoice test builder dot from USA, let's say, currency. So I'll need to add a method. If I want to add this, I'll need the class first, so I'll add that. When I say a simple invoice test builder, let's agree that it's got the build method and the uninvoice static function. So I'll need that. What I'll need as well for this one is that I'll need where is that? I'll need the USA constant somewhere. So I'll put this somewhere. I'll need that somewhere at some point. What else would I need on this invoice builder? I'll need a with method. So invoice test builder dot with a purchased book and some other stuff. Okay. So we've started to explore things, but we can still dig a bit deeper. Inside that, to be able to write this expression, I'll need to be able to have a purchased book, and for that, same thing as above. I'll need a simple purchased book test builder. And what else has this got? It's got an off method, so I'll need a purchased book test builder of, so a novel. Okay, so I'll need an off method, so which means that if I want to have that, I also need all this expression with the a novel, all this. So let's add that again. So a novel, blah, 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 all this. And again, here we see it's the same thing again. We'll need for that a simple novel test builder. So there's a Q&A here. I can see that. So yeah, so the question, I'll answer quickly. Yes, I'll do it for real. You might not need a mind map. You could do it with a file. So sorry, let me repeat the question first. Is the mind map something you do for real or something you often do in your head? It's very easy to do in a markdown file, for example, just an indentated markdown file, and this way you don't need the mind map, but the graph really helps to be able to roll it back from the bottom, as you'll see a bit later. So I think, how do you say it's answered? I don't know. I'll see later. So we've got a simple novel test builder, and what we wanted is a novel test builder dot costing. The nice thing about having the graph is that it removes it from your head. It removes some mental load, and it frees your brain for more important and interesting things. So we've got this costing thing, and let's look at the code. Maybe it looks like we're done here. So if we get back to our algorithm of the Mikado method, now it's time for revert. So I'm back here, and the nice thing now is that I've got something that is building. So I'm not blocking features, I'm not blocking anything. So let's try this one, a simple novel test builder. So let's add I'll do that just here. Class novel test builder. So what I want here first is a build method. So novel, if we remember correctly, it was, I think, domain book novel build. So we can make this const. And what we would like is to return. So we might need to, do we have it? Include domain book novel. Here we go. We've got that. And what do we need to pass here? The name. So that's fine. The price, the author, the language, and the genre. So we saw language, genre, price, name. We can provide sensible values, default values for that. But the author is more problematic. So here, what we can do instead is to go back to our graph and say that to do this, we'll need an author something. So we'll need a simple author test builder. And okay, so let's again revert everything we did and try this one. Class author test builder. Public author. So it's this one. Build const return. And what do we need for the author? I think we don't need much, so that's fine. So we need a name and a currency. And if so, I'm staying with John Steinbeck. Here, I would like the USA country. And it turns out we've got a step here for the USA country. So I'm rather going to do that. And again, I'm going to revert here. So the step is so small here that in real life I might just do it. But here I'm really demoing the thing. So my leaf is here, USA constant. That's what I need to start with. Namespace test countries. And we add domain country. We wanted this to be const. USA. Domain country. I think it was currency. US dollar. Domain country. Language. English. And this is building. And it's not failing the tests, which means that I can commit that. And I'll say test countries, that's it. Okay, I've committed that, so I can make this as done. And I can move on to the next step. And it was the author test builder. Author test builder. And for that, what we wanted is to have a domain book author build const return. And if I remember correctly, it was just John Steinbeck. And now that we've got our test countries, I can just use USA. And this should, just make sure this runs. At least if it builds, it runs. Okay, and so let's add the unauthor author test builder unauthor method. So this is really a simple syntactic sugar method. I'm just checking that it's building, running, everything. So now I can commit, and now we've got here a simple author test builder. And that's it. So which means that this step is done. This step is done too, which means that we can now move to this one. And I'll try that. So it was novel test builder, public, so domain book novel, return, so name, price, author, we have that, language, genres, grapes of wrath, price, let's say 10, author, so now we can use our builder, unauthor.build, domain, country, language, we'll say English because the book was written in English, and the genres. So it was domain book genre, and we'll provide an empty list for that. So is this working? Yeah, it looks like it is. Let's start the simple novel test builder novel. So we've got the helper method, the novel. Let's see that everything still builds. If we add tests, they would pass. Okay, so we've got that, which means that we can. So now we've got a simple novel test builder, and we can commit. So I'm not going to go through all the end of the thing like that because it would take a bit too long. So what I'm going to do instead is I'm going to get check out CPP builders and Mikado to show you what it would look like. So basically the end result is the same as the one using the builders. We've got the same reuse of code between the two tests. The only thing that changed is actually I didn't put the second one, I just put the first one, but we've got exactly the same end code. The only thing that changed is the way we went there. So let's see a bit this in more detail. So you saw if I had continued to the end, it would have taken me this time 40 minutes to get to the first invoice test, and only something like 7 minutes to add the second test. The time for the first useful commit, though, is only 12 minutes, so it's slightly above the brute force approach, but knowing that we're in a very simple legacy setup here. So there's in this plan, there's all the building in these 12 minutes, there's building the plan plus the first builder. So all the first phase of exploring doesn't touch the code actually. So it won't break anything. It's really safe work that you can interrupt at any time. Whereas here, all these 10 minutes are you're just piling and piling code that is not building yet. The another interesting things is how many useful commits. In this one, I made 11 commits. So yeah, by the way, I can show you the commits here. If we check this, I'll look at the questions after. If we see all the commits, we've got a commit, the first commit, which is the test countries. Then we have the author builder, then the novel test builder, the costing method. You see all the steps are there, very small steps. And every one of these commits increases the testability, which means that the first commit is useful for the others and will help everyone to test the code. What's nice is that we're committing every 4 minutes, very more frequently than before, and every commit is useful. And the nice thing is that we didn't went in any tunnel effect, so we're not blocking features. And so let's just summarize what we found here. If you're using both the test data builders and the Mikado method, there's still an overhead of writing the builders, but it's without a tunnel effect, so you're not stuck in that. You can write the test incrementally, and that's very important. If you remember the keynote, incrementally keeps your management happy, and that's what we're talking about here. You can test your legacy code incrementally using these techniques. You can take your time to do it, and slowly but surely you'll get to something that is more and more testable. There's cleaner test code, there's no duplication between the tests, and it snowballs, and that's the really interesting thing of that. So if you look at that, you start by starting a Mikado of test data builders. So you start to write some new builders. And what will happen is that setting test data will be easier, which means that people will start to add tests, even maybe on the author class we had before, these small little classes that you're starting to add builders on. Which means that as people use the builders, they'll make them better. And you're starting a virtuous circle here. But that's not only that, is that because as you're adding builders, people will start to add new composite builders, and you will add composite builders as well, meaning, for example, the novel test builder was using the author test builder, which means that you'll create even more builders which will make in turn the code even more testable. So there's really we're always improving situation in that. One thing I've noticed with these builders is that if you start injecting some builders in your test code, in your code, people will build on them. So even if you only add one small, people who didn't know the pattern will find, oh, this is very useful. I'll improve it, and I'll maybe add another builder that uses this one, and so on. And it's kind of spread on its own. You don't even have to do all the work. It kind of just propagates nicely. That's kind of magic. So if you want to practice this by yourself, you're welcome to use this repo. If you want to learn more about the code retreat format, which is the workshop format we're suggesting for this exercise, look at these links here. The idea of the code retreat, as I said, is that you're going to tackle maybe in iterations of about 1 hour or 40 minutes, you're going to tackle the same problem using different techniques. We call them constraints in the language of the code retreat. Otherwise, you can also try the same techniques on different problems to see how it works on different situations. And with that, in only a few hours, you really learn a lot about something. So it's really a way to experiment quickly. You can do this as a team, as a group, and learning will be even more, even faster. If you're interested a bit to learn more about the test data builders and the Mikado method, I suggest these 2 books and the website, the mikadomethod.info, which means that we've got 6 minutes for questions. So let me see. So we had one question. So you can put your questions in the Q&A. So we had one question. Is this mind map something you do for real or something you often do in your head? So I think it all depends on the scale. If it's something very small, sometimes you can just get away with it in your head because you try something, it doesn't work, you comment out the code, you try to fix something before, and then you uncomment your code, and it's going to work and it's fine. And it wasn't really an issue. But if it gets bigger, it's really pays off to have this represented or written somewhere because, as I said, you can remove it from your head and have more mental energy. It kind of reduces your mental load, which is an important thing when programming. And so you've got more added brain power to deal with the important things. And another benefit is that once it's written somewhere, you can share it with others. So if you want to organize together on the same graph, the same refactoring, the same tests, that's going to help you a lot. I don't know. Answer live. Oh yeah, it's done. That's how it was working. So, do you feel it makes sense to use this technique to create stories, tasks, or does it complement those so that it's easier to track what has been done with complex tasks? So it makes sense for what we should try to do. All the incremental coding techniques, they kind of help you to create stories that are independent from each other, and so you don't need so much to draw dependencies between them. But where it really shines is for technical work, so large refactoring of code, or sometimes you need to change your code to change the architecture or to make it able to deal with some performance issues or things like that. And for this, it's very tricky to see how you're progressing, especially for people that are not programmers. So I don't know, suppose your product manager comes and asks for some speed up in the program you're working with, but you need to do a lot of architecture changes for that, and it's going to take a few weeks or a few months. And it's kind of tricky to tell him, oh, we'll come back to you in 2 months, but trust us. And if for that you can draw a graph and share it with him and to look at, here are all the steps we need to do to get there. And then every week or every 2 weeks you show him, oh, we've done this and that and that, and he shows that you're actually progressing towards the goal. It's gonna improve the situation, build some trust, and see you progressing. Did you had to convince your management at some point that this is the best way to proceed in your case? If so, how? So this is kind of a hack, because if you're dealing with a management request, for example, improve the architecture to be able to deal with more performance, or to make the things faster, or to deal with more stress or something like that, then you've got a real feature that is asked for. So then at that point, coming up with a graph of all the steps, as I just said, to get there, you won't have to convince them. They'll be pretty happy to have that, because otherwise the alternative would be you telling them, oh, just trust us, we'll get there. And they don't really like that, because they're usually spending a lot of money on development teams, and that kind of makes them uneasy. But on the other side, if you can split your refactoring work in very small steps, you don't really need to ask for the permission anymore. It's just the development team's concern. You split it in very small tasks, and you just make sure that you do a bit every day. And no one is really going to bother you, because no one is tracking, I hope for you, no one is tracking you down to the half hour or something like that. So you can make this very small, do it regularly, and move on with that. So yeah, yes. So it turns out You can, some people use that. I've seen some articles of, so let me repeat the question, sorry. I don't like the idea of repeatedly reverting and rewriting the same code over and over again. Did you try to work with branches, shells to avoid that? So you can, yes, we did it. When the changes become too big, it can be helpful to have some kind of shells or some branch or some diff or something, or maybe sometimes just comments. But in the end, it's not as painful as it seems to be, because uh, if you repeat it a second time, it's just typing. The first time is usually a problem because you need to think, oh, what am I going to write? How am I going to do that? And so on. But then if it's just rewriting something you did before, it's usually kind of easy work. But yeah, you can still just maybe cut and paste things and put them aside if you want. And very often the thing you need to do after changes from what you had at the first time. Are you aware of what are other techniques that you also considered as option when choosing Mikado method? Yeah, beyond brute force. So there are plenty of other large-scale refactoring techniques. It's just for this talk, I've seen that build test data builders and the Mikado method, they really combine very well together, and it makes it easy, and it makes it a good alternative to just adding a test. I think the thing is about to close, but there are other techniques for large scale refactoring you might look into, like the bubble context or the strangler application, which are very interesting, or as well. What's the other? The golden master or characterization test. So these are very, very powerful technique to know. Yeah. So I'll just add the three references down in the chat. So thanks a lot. I think we're out of time. So see you later, and I'll try to stick around on the chat for a while. Thanks.